My name is Chris. I'm a co-founder and head of product at 514. We're the creators of the Moose Stack. The Moose Stack is an open source developer framework available in TypeScript and Python that makes it really easy to integrate real-time and agentic analytics into your application. And that's what I want to talk to you about today. Um, I want to make this a pretty kind of hands-on technical demo conversation. I'm going to talk for about 20 minutes. Hopefully about 15 minutes of that will be in the code and in the demo. And what I really want to show off is a reference application and a demo architecture that can demonstrate how to build in analytics powered by ClickHouse into your web application and into your AI analytics. But maybe I'll quickly first just kind of set up the challenge and the opportunity here. So what we're seeing more and more is that the future of analytics is actually in applications. So not like classic BI interfaces, but embedding analytics into your end user facing applications, or for internal users or your end consumers, whether that's AI chat or real-time analytics or automations within your business. Me and my co-founders used to run data engineering at Nike, and we were seeing all kinds of these use cases where developers across the enterprise were looking to embed analytics into their work. And we started 514 with this mission of bringing great developer experiences to the analytics stack to enable this. And what's really cool is that as you start to bring analytics into the world of applications and development, you open up the data to an order of magnitude, kind of more users, more potential. You've got not just data engineers who are able to build on data, but every developer within your organization can build on data. You've got not just specialist data analysts who are able to extract data, insights from your data, but all of your employees can. You've got not just internal BI being powered by your data, but your end users can actually get value from your data, increase in engagement, increase retention, increase lifetime value. And then, of course, you start to expose data not only to humans, but to your LLMs and your agents. Now, of course, the problem is that while it's easier than ever now with vibe coding and vibe engineering to build applications, when you start to layer on an order of magnitude more usage on top of your data, building the data foundation is actually getting harder, not easier. And if you don't build the right data foundation, then what you end up with is your database getting pounded by non-performing queries, and you get spinners in your dashboard, you get frustrated users. If you're running these queries against a production cloud database, you get ballooning costs. And if you've got developers trying to work with infrastructure architecture that was really built for BI and kind of the previous generation of analytics, then you're going to have really slow development life cycles, and you're going to cripple your ability to innovate quickly. So what we really see and are trying to create is a world where you can have a next generation data foundation that's built for embedding analytics into applications. And that requires a couple things. First, of course, you need the high performance real-time analytical infrastructure with databases like ClickHouse, streaming like Kafka and RedPanda. But you want that to seamlessly integrate into the tools and technology that you already have in your development flow and that you already have in your application stack, while still bringing in data engineering best practices so that you get the performance on these analytical workloads. And then, of course, you want it to be AI agent native as well. So this is the kind of data foundation that we're trying to help our open source users and our customers create. And with that, let me jump into showing you what this can actually look like. This is a demo application I've got that's powered on a kind of a fun, interesting data set. The data set is aircraft tracking data. So this is transponder data from all the aircraft in the air at any given time. And you can see this is just a Next.js front end. So, custom front end, I've got real-time analytics flowing here. And then I've also got AI chat embedded into the experience here. So I can start to ask questions of my data as well. You'll have probably seen demos like this before, but I can say, like, what is the average speed of all the aircraft, say, over 5,000 feet, and on autopilot. And What this chat is then going to do is use tools in an MCP that I've made available to it to be able to not answer me just based on the sum total knowledge of all humanity that the LLM was trained on, but by actually querying my underlying database. And what you see is that I got an answer back super snappy here. And that's because I've got that performant analytical database, in this case, ClickHouse, powering my conversation. So I get to have kind of a conversation fast response here from my database, and I get to see the average speed here. It adds a little color. This is all fun. And what I want to show now is the kind of how we go about solving the challenge of building an analytical backend that is usable by developers, gives us the performance that we need in the front end, works with the frameworks that we're already using here. So in order to create a backend to power something like this, you're likely looking at an architecture that looks something like this. So you've got your front end. It may have transactional components that are already powered by a transactional backend, like a Postgres or a MySQL or a Mongo. But now we want to add in an analytical backend. And so to do that, we're going to have to add in the specialized analytical infrastructure. But there's a lot we have to add into that as well to actually power this application. So we probably want some kind of data pipelining, ETL, maybe change data capture to pull in data from our transactional backend. Or in the case of this demo, we're actually pulling data from an API endpoint. We're going to need to ingest that into the database with a streaming buffer there to optimize the writes into the database. And then we're going to want to put APIs and an MCP on top of this analytical backend as well, so that the front end can directly query that data and that we can embed those analytics into our application. So there's a lot of pieces here. There's a lot of kind of boilerplate and glue and duct tape that you have to put together. And this is where the Moose stack can come in. So what I want to show you now is how we can build out this architecture using different Moose modules and different capabilities of the open source Moose developer framework to provide a unified interface for building out all of these different components of this relatively complicated backend and doing it pretty simply in a relatively small amount of code. So there's a couple features that I want to highlight as I jump into the code here in a second. The three here are one, Moose OLAP, which is the primary abstraction on top of the ClickHouse database that Moose gives you, where you get things like schemas as code, migration management. You get types in your queries, which I'll show you in a second. The second big thing is the local developer experience. What we found is that we wanted to create like an experience that mimics what you get with modern web development, where when you're developing locally, you're hot swapping in changes and you're seeing those changes live locally as you're developing. So you get very fast iteration cycles. And then Moose Stack also integrates natively with all the other technologies you might have in your stack, both in terms of data sources, as well as frameworks that you might be using to surface data up into production. So yeah, let me jump into my IDE now and let's get into the weeds here. So here you can see I've got a front-end Next.js application, and then I've got my Moose project for my analytical backend. And anytime I start developing in using the Moose stack, the first thing I'm going to do is start my local dev server. I'm going to do the same thing for my Next.js application. And so what you'll see here is as the spin is spinning up, what it's going to do is create a local mirror of my entire production stack. So Moose is going to be starting up ClickHouse in a container, RedPanda in a container, a TypeScript runtime in a container, temporal in a container for orchestration. And all of this is going to be available to then hot swap in code changes as I'm developing and give me that really tight iteration cycle. I can also, with one command, seed my local environment with data from my remote ClickHouse or my production ClickHouse environment. But now that this is up and running, what I can do is in my browser, if I come back to my application, instead of looking at the production app here, I'm now going to look at localhost. I'll give this a second to load. Yeah, so now you see I've got that whole application, both my front end and my back end with all the APIs and the MCP running locally on my laptop. So as I'm developing, I can see what's working, catch issues before they go into production. Another important aspect of the local dev server is it's got a developer MCP built into it. So you can plug in this MCP into your developer Copilot. In this case, I'm using Cursor, which is my AI-enabled IDE, but you could be using Claude Code or whatever Copilot you want. I connect my Copilot to my local dev server, and that local dev MCP is now going to give that my Copilot tools to help develop in my analytical infrastructure now. So for example, what that enables me to do is I can say something like, all right, I want to add a new Express API endpoint to my backend that returns average speed across all aircraft. And what it's going to do is use these tools to quickly understand what's going on in my application. It's going to be able to query the local database, see what data is available there, see the structure of the data, and then use all of that to inform actually writing the API in real time. And you can see here the Express API that it generated and the SQL query that it generated here. You'll notice the typed objects in the query. We'll come back to that in a second. But where this gets really cool is the first time it ran it, it then automatically tried to test it using the local dev tools, and it found that the API wasn't working. And so that it ran the tool to get the local logs, to get the context of what was going on. It found out it used a mount point or a route that was already in use, and it was able to fix it live on its own and get to an API that was actually working. And so this has been a really interesting learning for us, that the same tools that are helpful to a human developer, like quick iteration speed, like all the local context, like using patterns that are familiar and using fully typed languages, all of these are really helpful for an LLM or an agentic developer that's trying to build out an application as well. And you can see the results of that when you put these tools in the hands of an agent here. Okay, that was the local dev server. I want to show you now the actual architecture that we've built using the Moose OLAP and ClickHouse. So at the heart of every Moose application is this concept of data models. Data models, in this case, because this is a TypeScript application, are just TypeScript interfaces. In a Python application, these would be Python classes. And what you see is that with Moose, you just define the structure and the schema of your data as native interfaces. So this is the schema of the aircraft tracking data. This was actually automatically generated by my Copilot by looking at the API endpoint and generating the schema from it. But I've now got my data model as a source of truth, as a typed object in my code base. And I can create derivative data models on this. I can create derivative products, et cetera. But where Moose comes in, because this is all just standard TypeScript so far, is in instantiating this data model into my underlying infrastructure. So if I come to my ingest file here, what you'll see is that I'm importing in those data models that I defined. And now what I want to do is instantiate these as underlying infrastructure. So with a single line of code, what I'm saying here is create a table in my underlying ClickHouse database that's typed to the schema. Then I say create a streaming buffer that sits in front of that database, automatically batches writes into the database to optimize the write speed, and then create an ingest API endpoint also typed to that same schema and sit that API endpoint in front of the streaming buffer. And then with this API endpoint, I get automatic data validation included out of the box. And with one line of code, I can add a dead letter queue to route any events that don't match the schema to a dead letter queue instead of dropping them on the ground. So this is a lot right here, but in like 7 or 8 lines of code, essentially what I've done is built out this whole part of the infrastructure, the whole ingest. And I've got all of the boilerplate code, all of the glue and duct tape, all of the best practices for a highly optimized petabyte scale ingest pipeline here to land the data in ClickHouse. And then what I get from that is this table that exists now both in my local dev environment as well as in production when I push this into production, now exists as a TypeScript object within my code base. So now when I go to, for example, create API endpoints, I can import in this table object and then use that table object in my SQL queries. So I get end-to-end typing all the way through my SQL queries and even into my front end if I want to import that data model into my front end. So what this means is, for example, like this API endpoint is using the barometric altitude property. if let's say this data model changed upstream, or a developer on another team, removed this property, as soon as I comment this out, I immediately get errors in my application. I get errors in my SQL query saying, hey, this property that you're trying to query no longer exists. And I get that all built in just with the native capabilities of my IDE and the TypeScript language because of the typed connection now. Okay. So, the other thing that you get with Moose OLAP is migration management. So let me fix this so I don't get ongoing errors here. But similar to like ORM like functionality with a transactional database, we can manage migrations for you in ClickHouse. So another command that you get with the Moose CLI is a Moose generate migration. And what this is going to do is compare the local state of my code base and the local state of my infrastructure to a remote production database and automatically generate a migration plan for me. And you can see in the migrations folder the plan that gets generated here. And in this case, what it's planning to do is actually drop these two tables and recreate them with some differences. And what's nice here is I get a human in the loop, so I can review this plan. I can say, hey, that's actually not what I wanted. Like maybe in this case, I was just trying to rename a column. I don't want to drop the whole table and create the whole table, recreate the whole table for that. So I can modify the plan. And then when I push this into production, Moose will automatically execute this plan for me on my production database. It will sequence the DDLs appropriately so that there's no data loss, which can be a particular high risk when you're running on an OLAP database, which is not necessarily transactional. But Moose is going to handle a lot of that migration for you under the hood. Oh, the other cool thing to show is the MCP. So I talked about building APIs. And these APIs are all built using the Express framework. In this case, Express is actually managed by the Moose runtime. So I get the Express server spun up automatically for me with my Moose dev server. If you don't want to use the Moose runtime, you can still use these typed queries just by importing the Moose library into your application where you're using Express or whatever, Next.js, or sorry, Fast API, Next.js, Fastify, whatever API framework you're using. But similarly to how we wanted to create API endpoints here, we also want to surface an MCP for our front end. And where this gets really interesting is there's many kind of pre-built MCPs out there now. I think we saw earlier Altinity has one, ClickHouse has one. But what we've seen is that when you actually want to go to production with an MCP, surface that MCP to your end users, you likely want to customize that MCP for your actual use case. And the two most common things that you might want to do is add your custom authentication to that MCP, especially if you have a multi-tenant environment. And you might want to add some custom logic or some custom context to the MCP to make your queries more performant, to make them work better with the underlying data of your database. So similar to how you can create an API using your API framework of choice, you can also create your own custom MCP using the MCP framework of choice and sit that on top of ClickHouse with the Moose developer framework. So you can see here, we happen to be using this MCP server object from this very popular MCP library. We're also using Express to actually host the MCP server and put it behind an API endpoint that we can put auth on. And I'm not going to go through the details of the code here, but what you'll see is that there's a bit of logic where when the chat client passes in the query, the SQL query that's generated by the LLM, we're actually wrapping, or the MCP is automatically wrapping that query with some limits on it. But you can put whatever custom logic you want here to improve the performance of your MCP. But this MCP is now available at the /tools endpoint. And then all I have to do is in my front end, point the agent in my front end, my agent config, to this MCP server at the /tools endpoint. And using the MCP protocol, everything's just going to connect up and automatically work. So that's how I now get the MCP actually working embedded into my front end application. So I can again now I'm back in local dev. I can say like, what's the average aircraft speed? And now I'm running against my local MCP. It's hitting my local database. It's running this query. It's snappy, fast, and I get the chat embedded in my application. Okay, I know we're coming close on time. The last thing I'll say is that if I want to get to production with my application, this has all been local dev, but if you're using Boreal, which is our hosting platform, then all you have to do is create a new PR, and Boreal will automatically pick up that PR and deploy a preview branch for you. We can host your whole application in production for you. And got a quick slide on this. And so we can manage the infrastructure. We'll give you a great local to cloud kind of developer experience where we can manage these migrations for you. We'll integrate with CI/CD, with GitHub, create preview branches for you. And then the deployment models we support are fully hosted, of course, but you can also bring your own infrastructure, bring your own ClickHouse. If you're using Altinity, for example, you can connect your Altinity ClickHouse into Boreal, or we can deploy entirely in your cloud with a BYO cloud model. But yeah, that's Boreal, and I think I'll leave it at that. Again, my name's Chris. 514 is the company. Moose Stack is the open source framework. Go check us out on GitHub. Give us a star if you like what you see.